My name is Haley Peck, and my Stat 200 project is titled MLB Pitchers. My research question was, is there a relationship between the weight of a pitcher in the MLB and the speed of their fastball? My variables are, my explanatory variable is the weight of the pitcher, which is continuous, and my response variable is the speed of the pitcher's fastball, which is also continuous. In order to collect this data, I used MLB player statistics from MLB.com and went through each individual team in the MLB to get the statistics of their two starting fastball pitchers. I got the first two starting fastball pitchers from each team in the American League and the first two starting pitchers from each team in the National League. The statistics include the name of the pitchers, the team that they are on, their weight, and the speed of their fastest recorded fastball. I came to a dilemma when I realized that some of the starting pitchers were not fastball pitchers, so a few teams have their starter and their second backup instead of two starters to make sure that they were all fastball pitchers. At first, I had collected height as well, but realized that I was more interested in understanding if weight had an impact on speed, and since weight had a bigger range, I decided to use it instead. Though each team gets new pitchers pretty often, there's a chance that MLB.com might not be updated and has the pitchers from 2017. I decided to use their fastest pitches even rather than their average to make the data collection a little easier. Due to the fact that I was primarily interested in the weight and the speed of the fastball pitcher, I did a summary statistics of each just to find out the average and range of all the data. As you can see, the mean of the weight is about 220 pounds, and the mean of the speed of their fastball is about 92 miles per hour. I decided to construct a 99% confidence interval for the correlation between the weight of the pitcher and the speed of their fastball, and I used bootstrapping methods and StatKey. I used the interval to determine if the correlation is significantly different from zero. As shown on the slide, I constructed a scatter plot of weight versus speed, speed being x variable and weight being y variable, and graphed them to see if there was any correlation. I still found Pearson's correlation of weight and speed, which was negative 0.014309, and the p-value, which was 0.9010. So since Pearson's correlation is negative 0.014, that means it is a weak correlation as it is far away from 1 or negative 1. And since I found that the p-value was 0.901, it was greater than 0.05, and so I concluded that I did not reject the null hypothesis, and thus there was not significant evidence that there was a relationship between the weight of the pitcher and the speed of their fastball. So for considerations in future work, the results were that there is not a relationship between the weight of an MLB pitcher and the speed of their fastball. For my data collection, some concerns that I had was that the website may not have been updated, or pitchers that were once starting pitchers may not be anymore, or they might be hurt or out for the season, and that would mean it's not as accurate as it would have been. Some confounding variables. One is that I was comparing the American League and the National League, which has kind of a difference in skill level. So a weaker team may have a weaker pitcher, and comparing him to a stronger pitcher from a different team could be a problem. And then another one I came across is the height of the pitcher is a confounding variable. For future work, maybe I could see if the height would have an impact, use other type of pitches such as curveball or slider, and even maybe do a chi-squared analysis along with the correlation analysis. Although it was pretty evident on the scatter plot that there was not a correlation, I still found Pearson's correlation of weight and speed, which was negative 0.014309, and the p-value, which was 0.9010. So since Pearson's correlation is negative 0.014, that means it is a weak correlation as it is far away from 1 or negative 1. And since I found that the p-value was 0.901, it was greater than 0.05, and so I concluded that I did not reject the null hypothesis, and thus there was not significant evidence that there was a relationship between the weight of the pitcher and the speed of their fastball.